Alright, let's go for another one. So this time we are having a question where we have to prove parallel lines again. Okay, so let's see what is given to us. Consider the figure where chord PU is equal to ST. Did they indicate that for us? Yes, they did. As you can see there are the indications of equal lines. You know the story about the equal lines. We are going to use that for sure. 2.25.1. If T2 is equal to X, where is T2? Let's go and highlight T2. There you go. There is T2. Right. If T2 is equal to X, find 3 more angles that are equal to X. Okay, let's go. Remember, equal chords or equal sides subtend equal angles. Okay, equal chords or equal sides or equal lines, they subtend equal angles. So we have equal lines here, PU and ST, which means they will subtend equal angles. What does that mean? Which other angle is subtended by an equal line? ST. It's Q3. Yeah, it's Q3. It's Q3 and U3. Hope you see that. Yeah, so that is good. Already you just find 2 angles that are equivalent to X. So let's go. Angle Q3 is equal to X, or in order for it to be precise, let's go for angle Q3 is equal to angle T2, and they are equal to X. Y, it's equal sides or equal chords or equal, you can go for chords. Let's go for chords. Equal chords subtend equal angles. Right, now we know. Also on this one U3, you can go for equal chords subtend equal angles, or you can go for angles on the same segment. You can see there's a bow tie. This angle, these 2 angles are forming a bow tie. This one and this one, they are forming a bow tie. So let's go. U3 is equal to Q3, and they are equal to X. How come? Angles in same segment. Right, now the last one can be Q1. Q1 is subtended by PU. PU is equal to ST. ST is subtending Q3. Q3 is equal to what now? Equal to X. So what does that mean about Q1? Also Q1 will be equal to X. Angle Q1 is equal to, let's equate it to, you can also use same seg. You can equate it to T2. They are equal to X. Angles on the same segment. Here's a bow tie. My lord, there is a bow tie. There you go. This equal to this. Bow tie lawyer, as you go to food. Bow tie lawyer. So angles in the same segment, or you can go for equal chords subtend equal angles, of which that time, for that one it will be equivalent to T2. Yeah, it can also be T2 because they are subtended by PU, which is equal. It's common for both. Or you can go for Q3 because they are subtended by the equal chord ST. It's up to you. So that is that. Now prove that US is parallel to PT. US parallel to PT. let's go and highlight US and PT so it can be easy. US and PT. Okay, let me just start by highlighting our angles that are all equal to X. Another one, it's this one. And then do we have something else that is equal to X? No, I think we're fine now. Okay, because I'm sure this one is going to help for what we are about to prove now for parallel lines. So we're supposed to prove that US, there is US. Let's highlight the line US parallel to PT, parallel to PT. So how are we going to prove that? Is it possible to prove making use of corresponding? It's complicated. Is it possible to prove making use of co-interior? Nah, it's complicated. Is it possible to prove making use of alternating angles? Yes. Do we have a Z? Yebuke. We do have angles that are forming a Z. And they are already proven. They are already proved as equivalent to X. So what do you say? T2 is equal to U3 and they are equal to what? X. The reasoning behind that, it's proven. We have proved so. Proven. Now we can conclude, therefore, US is parallel to PT. How come? It's alternating angles equal. Because alternating angles are equal, that means we do have parallel lines. That is that. Don't forget to check on the study guide, Saga Maths for Africa, because I'm making use of it. Ilinki ikona with description. Click on it, check the study guide sabo, you buy it, then you're gonna be fine. Such an amazing study guide. Thank you for watching, Pet. Away.